Hello from Denver Center Weather. My name is Sarah McCorkle and I will be recording the online version of the 2025 Summer Weather Refresher. And I'm doing this on behalf of the other aviation meteorologists here at Denver Center, including Greg Gilliatt, Greg Master, and Scott Lockhart. Hope you enjoy. Across Denver Center, we have various summer season hazards, including thunderstorms, fires, and high-density altitude problems. And under the thunderstorm category, we have a lot of unique hazards that arise from that, including microburst activity, Denver cyclones, and all that fun stuff, and I will talk about that in the upcoming slides. First summertime hazard we will talk about will be thunderstorms, and you can see various pictures of thunderstorms, cumulonimbus clouds, even tornadoes, all courtesy of NWS Boulder, just to get us all excited for talking about thunderstorms here. For thunderstorms to get going, we need a few ingredients, the first being moisture, and there's no problem getting moisture into Denver Center just the way the United States is set up. We can get moisture from various different sources, including the Gulf of America, transporting moisture up through the southern and central plains. And then as well, we can get moisture from the Pacific and more monsoon-like setups. Also, we need some kind of lifting mechanism, and for Denver Center, oftentimes that is from the mountains. We have a beautiful mountain range across our airspace, and that is usually the source for getting these thunderstorms to start going. Also, surface cold fronts, surface warm fronts, the jet stream outflow boundaries are other sources of lift that we also get across Denver Center. And then we need some kind of instability. We need unstable air for this air to continue to rise as it is forced over the mountains rather than stabilizing and coming back down to the surface. So these are some ingredients we need for thunderstorms. Now we'll quickly talk about the life cycle of a thunderstorm. The first stage is the towering cumulus stage, where little clouds start to build in the vertical thanks to all the ingredients we talked about before: lift, instability, and moisture. And we can start to see some pilot deviations as these tops get up to flight level 200, even though nothing might be showing up on radar quite yet. In the mature stage, these clouds can easily get up to flight level 400, 450 with the help of a strong updraft. And then finally, we have the dissipation stage where rain and precipitation isn't really happening anymore, but we still have those clouds lingering up high in the atmosphere, so still could get some pilot deviations even in the dissipation stage. Now we'll take a quick look at the thunderstorm diagram. You can see there needs to be a strong updraft to sustain these thunderstorms, and updrafts within strong storms can routinely reach up to 50 miles an hour, and in the strongest storms up to 100 miles an hour. You can also see the Anvil area of a storm extends out 10 to 20 miles from the cell of the thunderstorm, so we can get deviations even 10 to 20 miles outside of the thunderstorm itself. And here's a look at what one of these thunderstorm structures looks like in real life. You can see as the air is sucked into this updraft, it is rotating, and this updraft likely extends many thousands of feet up in the air. So just wanted to show an example of what one looks like in real life. Okay, now we will discuss the en route thunderstorm hazards, which include large hail, which can be very damaging to aircraft, severe or extreme turbulence, updrafts and downdrafts exceeding 6,000 feet per minute, lightning, and icing. And then we have different hazards that can impact TRACON and Denver Tower airspace. We have microbursts and wind shear that we have to worry about, and I'll talk more about that in upcoming slides. Strong surface winds from outflows, large hail, and you can see a picture of large hail from a 2017 storm in the radar loop. You can also see as well. This was actually the second most costly hailstorm in United States history. So obviously, if planes are trying to depart at the west gate, that would not be very wise with all these severe thunderstorms moving into that airspace. Also, we can have IMC IFR conditions, severe icing, and tornadoes and funnel clouds. And you can see here on the right is a picture of a tornado from June 12, 2022. And here is the corresponding METAR that was associated with it. So that is just goes to show the additional things we have to worry about in the summer. Also, we have to worry about dry microbursts, and what are they? They are intense short-lived downdrafts that result in strong winds and wind shear at the surface. They are most common in the western U.S. and high plains, and they occur when there is some instability aloft, but dry air at the lower levels. So the rain doesn't necessarily come to the surface, but all that energy from aloft does. So we can see in this picture on the upper right what it looks like in real life, dust being thrown around everywhere. And yeah, they're often associated with virga, as like I mentioned, that rain does not make it to the ground. So that's a sign that maybe we could start to see some dry microbursts, which are obviously very hazardous for aircraft as they move through one of these microbursts. The rain isn't necessarily what's going to do the damage, but as it gets out of the dry microbursts, the intense tailwinds can cause a lot of damage to aircraft and are very dangerous. So what does this actually look like? What are the impacts of microburst activity at Denver? So we can get winds in all different directions and we get lots of wind shear. This is an example of what we can see at center weather. We have all the runways at Denver on the left. You can see 16 right, 16 left, all the way down to 34 right. And you can see wind shear alerts, WSA, as well as MBA microburst activity. So you can see 16 right, for example, is showing a loss of 20 knots as they make it across the runway. And then on the right, you can see the wind directions. So we have anywhere from a southeast wind, 130, to a southwest wind, 220, northeast wind at 35 left, and then a northwest wind at 35 right. So you basically are getting winds in all directions at a given time, which is very problematic for planes trying to land. So microburst activity has serious impacts at Denver, including prolonged shutoffs and diverts. An example from 2023, we had a prolonged period of wind shear and microburst activity at Denver, which resulted in 70 diverts. And you can see from this radar image, it's not really too impressive as far as thunderstorms go, mainly just some showers. But you can see from the velocity radar image, we have strong winds out of the east, and then they quickly turn to strong winds out of the south. And then you can see in the METAR on the lower left, they eventually go back to the northwest. So as well, you can even see some blowing dust. So winds can change very rapidly in a short amount of time. Some other unique Denver summertime hazards include the Denver cyclone or the Denver convergence vorticity zone. And while we still do get these in the winter, they can be more problematic in the summer because we can get thunderstorms that initiate off the Denver convergence vorticity zone or DCVZ boundary. And what is it? It's a small scale or graphically induced circulation that results in converging winds. Just with the way our topography is set up, with the Cheyenne Ridge to the north, Rockies to the west, and Palmer Divide to the south, we can get these circulations with the presence of southeast wind. And the challenges with this, we get rapidly changing wind directions in a short amount of time and distance, different wind directions on all runways, and like I mentioned, the thunderstorms can initiate off that DCVZ boundary. Here's an example of what one looks like. You can see that boundary is sitting over the field, and with that we're getting winds changing in a counterclockwise motion. And not shown here is thunderstorms initiating, but that can happen with the right environment. All right, changing gears to wildfires. So wildfires can create very problematic situations in the summer as well, with reduced visibilities from smoke at the surface or aloft, marginal VFR to localized IFR conditions, which will result in reduced arrival rates, possible impacts to Denver TRACON arrival gates, and mountain obscuration impacts. A recent wildfire example from July 29, 2024, the Alexander Mountain Fire impacted the communities of the northern Colorado Front Range. And this, you can see from the satellite loop, as the smoke got going, fire got going, the smoke is being transported east, and that created some problems for planes making their final approach into Denver. In fact, on this day, the northwest arrival gate went to one route due to the smoke impacts. Also, you can see there's cumulus clouds bubbling up, so we can have multiple hazards to deal with at once, including deviations from convective buildups. Then we have high density altitude, which the impacts from this include reduced power, thrust, and lift, longer takeoff and landing rolls, slower rate of climb, lowers aircraft service ceiling, and 7.3% of weather-related accidents in the U.S. are due to high density altitude. So on very hot days, especially over the mountains, we will have to pay attention to density altitudes. Next, we will discuss products that can be issued to enhance situational awareness for when there are thunderstorms ongoing across the airspace. So we can issue center weather advisories to let pilots and air traffic controllers know when we're starting to see thunderstorms develop. And not only is it to let you know of thunderstorms, but it's to let you know of severe icing, turbulence, all the associated hazards with thunderstorms. It's typically valid for 1 hour and updated hourly, issued incrementally for a new thunderstorm area, so going from 101 to 201. And then if we're issuing it for a similar thunderstorm area, it will go 101, 102, etc. And air traffic controllers, at least at Denver Center, will be able to see it under their PIDs, under convection, and be able to solicit PIREPs for it. An additional product to enhance situational awareness and warn pilots and air traffic controllers of convection is the convective SIGMET, or the CSIG, which is issued by the Aviation Weather Center. That also tells similar information as the CWA, including what direction and speed the storms are moving and what flight level the tops are getting to. And this is usually preceded by a center weather advisory, so we go ahead and issue the center weather advisory, and then it's taken over by the Aviation Weather Center. Then for those at Denver Center, there is some internal products we issue that can enhance situational awareness even further when we think the arrival gates will be impacted by thunderstorms. The green being some pilot deviations will be possible, so a low impact. The yellow being a medium impact, so we could be down to one route, or red, where we expect the entire arrival gate to be shut off. So this is just another tool to know when there might be holding at a gate, when we expect thunderstorm activity to be bad in that area. So just a reminder to convey all important weather information, including SIGMET, CWAs, AirMets, and PIREPs. Soliciting PIREPs, even in the summertime, is very helpful. For example, the Equitop flight level information is very helpful for us too, to see what the pilots are really seeing. It's helpful for us and the pilots, so we appreciate them very much. And of course, if you have any questions about the weather or want to know more, you can always contact us, and we are happy to help. Thank you so much, and appreciate you listening to this summer weather refresher. Have a good day.